Assalamualaikum and salam sejahtera. I'm Razimah Abdul Rahim from PPD will present my paper with a title of Development and Evaluation of a PV Solar Trainer with Integrated Cooling System for Enhanced Practical Training. For introduction, solar energy has become the perfect alternative to reduce costs. This paper aims to develop and evaluate a PV solar trainer integrated with a cooling system. The PV solar trainer with a cooling system represent a northward advancement in solar energy system, addressing a critical issues in region of high temperature. The system employs a cool mechanism utilizing fans and water pumps to counteract the efficiency reduction experienced by solar panel in hot climates. For the problem statement, why we developed this trainer? First, Polytechnic Port have two diploma programs which related to green. One is Diploma in Electrical Engineering Green Energy and the other one is Diploma in Electrical Engineering Energy Efficiency. Both programs have learning related to PV, solar, and there are also students did their final year project using PV solar. So that we felt lack of comprehensive learning experience for students and trainees in exploring PV solar trainer with a cooling system. The challenges lies in the impact of the climate and weather condition on the performance and efficiency of the system. Third, need for an innovative approach to environmental and sustainable education by developing a PV solar trainer with cooling system. And lastly, to ensure a holistic understanding of solar technology and its application while navigating the complexity of temperature regulation. For the objective of this work to build a PV solar panel with a cooling system that can effectively demonstrate the principle of solar energy generation. Second, to develop coding for the PV solar operation of the cooling system. And last, to analyze the performance of PV solar trainer and cooling system. For the methodology, we describe first for the PV solar trainer. The construction of the PV solar trainer involves integrating various components to establish the comprehensive solar and cooling system. Key components include solar panel, battery, solar charger, controller, inverter, watt meter, fan, water pump, speed controller, Arduino, and DHT11 sensor. The PV solar panel with cooling system has 100 times 90 times 90 centimeter dimension, featuring poly solar cell in a 164 times 99.2 times 4 cm solar panel. This is the block diagram of the PV solar trainer with cooling system. There are three main blocks, which are PV solar charger, controller, and battery. There are four sub-blocks from the battery are connected, which are Arduino, water pump, fan, and inverter. The inverters are further segmented with the initial two providing power to socket plugs, while the subsequent pair is designated for USB port to facilitate the connection of electrical appliances. This is the comprehensive flow chart of the project, encompassing both hardware and software aspects. Project description. This project is divided into two interrelated segments, starting with the hardware interfacing creation and software development and integration using the Arduino. The hardware phase encompasses the frames construction, trainer board, components, wiring, solar panel installation, and continuity tests. And the software part focus on the Arduino-based code, crashing automatic cooling system, control incorporating the temperature and humidity with the DHT11 sensor. For the hardware development, first we construct the first Step involve the construction of the iron frame to support the solar panel. Trainer board creation. The board includes the development of dedicated trainer board to house various components. Third, component installation. Key components such as watt meter, solar charger controller, battery, fan and water pump are installed on the trainer board. Project-based integration. Components are installed onto the project base, ensuring the robust or organized setup. Fifth, wiring. The wiring for all components is carefully executed, creating the functional connection between different parts. And six, solar panel installation. The panel are affixed to the construction frame. And last, continuity test. The continuity test is conducted to ensure the seamless functioning of the entire solar system. For the software development, first Arduino code creation. The software development phase begin with the creating code using Arduino to control the PV solar cooling system. Second, code integration. The developed code is integrated into the Arduino platform. Third, upload the Arduino. The final code is uploaded to the Arduino platform to govern the fan and the water pump function through the two-way relay. And the last, sensor integration. The DHT11 sensor is integrated with the Arduino platform to monitor temperature and humidity level on the solar panel. So for PV solar certification, types of polycrystalline types. Maximum power output is 270 watts. Maximum power voltage 31.8 volt. Maximum power current 8.5 ampere. Weight 20 kg. Dimension is 164 times 99.2 times 4 cm. This is the schematic diagram. This schematic diagram, the operational logic of the software circuit is initiated when the DH11 sensor registers a high temperature of 41 degrees Celsius. The information will be shown on the LCD and the solar panel moisture level. Subsequently, the circuit will activate the fan and the water pump connected to the two-way relay for 30 seconds before changing operation. The system remains dominant until the DHT11 sensor detects another instance of 41 degrees Celsius temperature. And the result shows, the graph shows time versus current, voltage and power. The measurement is recorded in 10 minutes for 1 hour. The highest power value was 136.96 watts, while the voltage was 32.46 volt and the current value was 6.06 ampere. At that time, solar panel provided full lighting from the sun because there were no clouds. At the 60 minutes, the result shows decrease in the power of 34.62 watts, while the voltage was 20.98 volt and current was 1.65 ampere. At this time, the sunlight was covered by clouds. The result analysis of the correlation between time, temperature and humidity with the cooling system are conducted over 1 hour in the evening. Data is logged every 10 minutes given the placement of the two DHT11 sensor on the front and back of the solar panel. There are dual reading for each temperature and humidity data point. The highest temperature recorded is 36 degrees Celsius for temperature 1 and 37 degrees Celsius for temperature 2. At the 10 minute, the analysis was carried out in the evening and the weather was sunny. The lowest temperature that has been recorded is 29 degrees Celsius for both temperature sensor. The low temperature was recorded in 60 minutes due to the dim and not too hot weather condition. This table shows the result of the data on time with the humidity. There is a difference between humidity 1 and humidity 2. The sensor for humidity 1 is at the bottom of the solar panel, so that is less exposed to the heat, causing the humidity to be high. Meanwhile, humidity sensor 2 is placed in the front of the solar panel, causing to be more exposed to the heat and causing the low humidity. For the conclusion, development of the PV solar trainer with cooling system represents a significant stride in enhancing the learning experience associated with the solar technology. Second, the finding affirm the practicality and educational value of the solar trainer with cooling system positioning is as a valuable resource for understanding and optimizing solar technology application. Third, the PV solar trainer with cooling system not only serve as an educational tool but also pave the way for potential advancements, ensuring continuous improvement and innovation in the field of the solar energy. Lastly, the work lays the foundation for future enhancements that can contribute to the sustainability and efficiency of solar technology and various environmental conditions. That's all. Thank you for hearing.